In this lecture, we'll learn how to find the volume under the graph by integration. Let's say I have this graph right here. This is my y-axis, this is my x-axis, and my curve is this f of x, and they ask us to find the volume if f of x is rotated 360 degrees about x-axis, right? So I'll simply use this formula. Right now I'll tell you the formula and how to use it. Then later on I'll tell you how this formula was actually derived, how this formula actually came to being. So what we'll do is, if they ask you to find the volume of this figure when it is rotated 360 degrees about the x-axis, so it will be somewhat like this. The figure will have a sort of shape like this. Let me draw it, clear it out. So it will be this is A, this is B, this is point B, this is point A. It will be somewhat like this. Alright, and x-axis will go right through it. This. Alright, this x-axis. So it will form a shape somewhat like this, a portion of a cylinder, but not a uniform cylinder. So if they ask you to find the volume by integration when this portion AB of the curve f of x is rotated 360 degrees about AB, just simply use this formula, which is pi B to A f of x squared dx. Alright, f of x squared dx. This will give you the volume when f of x is rotated 360 degrees about A and B. Alright, so see, it's pretty simple. Now what if they rotate the object around the y-axis? That's pretty simple too. Let's say I have the curve, this is my curve, and now A is right here and B is right here. They rotated this portion around the y-axis and it will form a shape somewhat like this, right? A cylindrical type shape. They have asked you to find the volume of this figure, of this portion when this portion is rotated about 360 degrees about y-axis. So let's say this was our function f of x equals to x cubed. So this is this formula when it was rotated around the x-axis. This is basically pi into b a y squared dx, where y is in terms of x. Let's say y here was x cubed. So this will become b a pi x cubed squared dx. Alright, now here in this case y is x cubed again, but they've asked us to find the volume when it is rotated about the y-axis, not the x-axis. Now A and B are the limits on y-axis. So what we'll do is we'll do BA x squared pi into BA x squared dy. So what do I mean by that? X equals to y cube root, right? So we'll put y here. So this will give us b a pi y 1 by 3 squared dy. So when they ask you to find the volume when it is rotated about the y-axis, you need to use this formula, alright, in which there are x is expressed in terms of y, and when they ask you to find the volume when the shape is rotated through x-axis, you use this formula in which y is in terms of x, right? Because the terms here and this term here dx or dy must be same for integration to occur. Alright, now we'll learn that how did this formula actually came about. So I'm going to write these two formula again, note them down. when rotated through x-axis be a y squared dx, when rotated through y-axis be a are limits on the y-axis, x square dy. Alright, learn these two formula by heart. Now we'll learn that how did this formula actually came about. Alright, so let's say I have a curve. I'm going to draw the curve. First let me draw the two axes. This is my y-axis, this is my x-axis, and my curve is right here. This is point A, this is point B. Now I need to find the volume of the shape when this portion right here is rotated about the x-axis 360 degrees. Alright, so it will form a shape somewhat like this. This is A, this is B, this is my shape right here, and my axes will be these. My x-axis, and this is my y-axis. Alright, so now let's break this down a little further. Let's say I have this area right here which has this portion right here with a very minute width, with a very low width. Let's name that width d of x. Now if I rotate this area just like this in the same manner, so I'll get a shape like this. Alright, it will be a cylinder, almost a cylinder, with this height d of x, and its radius will be starting from this point. This was my x-axis. Alright, so this is my radius, this thing. Alright, so this radius will be what? F of x, right? Let's take this as x. So our radius will be f of x. Now the volume of a cylinder is pi r square h. Now in this case r is what? F of x squared, h is dx. Now let's say I have numerous cylinders between A and B. Infinite cylinders. Now I need to add the area, I need to add the volume of all of these cylinders, right? So I need to actually put a summation symbol there. I need to integrate them, I need to add them up. So if I use the basic formula for integration which you have learned in the previous lecture, what I'll do is I'll do this pi f of x squared dx. If I apply the basic formula of integration on this, the true formula of integration on this, I'll get this, right? So less than b to a. So pi is a constant, pi will have no effect, so let's write pi outwards of this bracket. ba will be left with this formula. Get it? Which is this right here, this thing. And from this thing we got this thing. We just inverted the axis in this. We worked through the y-axis. Here we worked through the x-axis. That's how this formula right here was originated. Right? Now in the next question we'll do some practice example so that you understand this further. Now do note that by using this formula you'll get the volume when this portion was rotated a whole 360 degrees around the x-axis. if they ask you to find the half, if they say that the portion was rotated 180 degrees, and then they ask you to find the volume when the portion was rotated through 180 degrees, you'll use this formula. From this formula, you'll get the volume of the portion when rotated through 360 degrees. Then you'll divide it by 2 to get the volume of half the portion. Alright. If they say that the portion was rotated only 90 degrees, then you'll use this formula. From this formula, you'll get the answer when the portion was rotated 360 degrees and divide this formula by 4. So you'll get the answer when the portion was rotated only 90 degrees. Alright. Correct. So now in the next lecture, we'll do a practice question so that you understand this better.